For problem 50, we're asked to solve the following system of equations. Y equals 4x minus 5 and y equals x plus 4. We're in luck here because they're already both solved for y. So since they're both equal to y, that means they both have to be equal to each other. So we're just going to set them equal. 4x minus 5 equals x plus 4. Now we're going to solve for x. So we want to get all of our variables on one side. So let's subtract x from each side. We have 3x minus 5 is equal to 4. Add 5 to each side. 3x is equal to 4 plus 5 is 9. We need to divide each side by 3 to get x is equal to 3. So we've solved for x. Now we need to solve for y. To solve for y, we pick one of our original equations. I've picked y equals x plus 4, simply because it's a simpler problem, less work to do. So y equals 3 plus 4, y equals 7. Then we would write our solution as our point of intersection. Remember, x comes first, so we have 3, 7. Write the rule that represents the number of tiles in this pattern. Okay, when we write a rule, we have y equals mx plus b. M is our slope, and b is our y-intercept. Now, we have a number of different names for slope and y-intercept. Let's talk about what they are in the context of tile problems like this one. Our slope is our growth factor. How many tiles are being added each figure number, between each figure number? And then in terms of tiles, our B is our figure 0. It's the number of tiles in figure 0. Well, in order to find our equation, that means we have to know how many tiles are in figure 0. So let's work backwards. Okay, if figure 3 has how many extra tiles out here? 1, 2, 3, 4, 5. How many does figure 4 have? 1, 2, 3, 4, 5. So these 2 are extra. So we've got 2 extra here. We had 5 here. We have 3 here. So let's shade in these 2 extra. So that means these 2 will be extra from figure 1. And then we need to work all the way down to figure 0. Okay, what else is changing? Let's look at the top. So this has 2 at the top. This has 3 at the top. So this one on the top was added. This one has 4, so that one on the top was added. Okay, so this one must be added from figure 1. Now, is there anything else added? Well, let's look at his little tail. So this tail has 3. This one has 4, and this one has 5. So that means this has been added. This has been added, and this has been added. So if we work backward, that means figure 1 has only 1 tile at the top. It has 2 tiles on the tail. And it has 2 tiles right here. Okay, and then we need to work backward. So we would shade in the top part. We would shade in these 2. And we would shade in the bottom tail to see what was left for figure 0. Well, that's easy. Figure 0 only has a single tile. So let's plug in to find our rule. Y equals, what's our growth factor? How many did we add each time? We added 1, 2, 3, 4. So 4, we have our x. And then how many tiles did figure 0 have? It had 1 tile. So plus 1. And that's our equation here. Y equals 4x plus 1. Write the equation that best represents this line. Okay, well, let's look. Where are our axes on this graph? So we have our x-axis here and our y-axis here. Again, our equation requires a slope, which is our m, and a y-intercept, which is our b. Okay, where does the line cross the y-axis? Crosses right here when y is what? Well, let's see. What is our scale? So if 10 is up here, let's see, we must have been counting by 2, 4, 6, 8, 10. We must have been counting by 2s. So this would be 2, this would be 4, 6, 8. So our y-intercept, our b, is 8. And now we need to find our growth factor. Well, we know this point right here. We also know this point right here. So let's use a different color so it's easier to see. We're going to count our rise over y. So our delta y, our rise, is 2, 4, 6, 8. And our delta x is our scale the same? I go from 2 to 4. No, our scale is not the same. We're actually counting by 1s on the x-axis. So our delta x is 2. So slope is delta y over delta x. So we have 8 over 2, which is 4. Therefore, our equation of this line is y equals 4x plus 8. 4x plus 8.